Chalo. So we'll continue the kinematics and dynamics of rotational motion. And next one is rotational kinetic energy. And rotational kinetic energy का क्या relation है? Tell me, rotational kinetic energy का क्या relation है? Formula क्या है? Before linear में it is half mv square, and rotational kinetic energy will be
half I omega square.
खत्म, half I omega square. इसके बेस में we have to do some questions, small questions करेंगे. Okay, चलो हो गया. So omega is angular velocity rotating about any body rotating. इसका angular velocity, and this we are talking about purely rotation. It is not moving now. Okay, pure rotation. No other videos, both of them. हाँ, कब बेटा?
Yeah.
करो. Two bodies having the moment of क्या?
No, so 1 second.
Yeah.
Okay.
So moment of inertias are given about the axis of rotation. If the kinetic energies are equal, then angular velocity is how much? Ratio is how much? Omega
Sir,
1 में
√2:1.
देखेंगे. प्रणव करो. So kinetic energy formula you got right? Half I omega square.
That's a √2:1.
Yes, √2:1 is answer. Next. A solid sphere of mass है. So solid sphere एक one object is there. Solid cylinder is there of same mass, same radius, rotating about geometrical axis with an angular velocity twice that of sphere. Okay. So cylinder का angular velocity is twice that of sphere. The ratio of the kinetic energy is how much? You know moment of inertia, right? Yeah. So we're asking kinetic energy of the sphere by kinetic energy of the cylinder.
So 1:5.
देखेंगे. ग्रुप करने दो.
Sir, moment of inertia of cylinder is mr square by 10, right?
No, why am I asking? Cylinder is ये वाला ना moment of inertia. कौन सा? Cylinder is nothing but solid cylinder is so much. Looking top view में देखने से कौन सा दिखेगा?
Oh, mr
Disk.
square by 2.
हाँ.
Yeah, sir, 1:5.
Yes. So it is answer is 1:5 is answer. ये sphere भी आता है ना? 2/5 mr square, right? Now work done by torque. So already you know how to find work done for linear. If for variable force, what is the formula we'll use for variable force का work done? Integral r1 to r2 f dot dr, right? This for linear we learned in when the force is variable. And can you tell me rotational motion में क्या होगा? Compare always rotational. No new formulas, same formulas.
Torque into d theta.
Tau dot d theta, right? So theta का displacement theta 1 to theta 2. Tau dot d theta. So what done आ गया तो we can go for work energy theorem also. Stop it. Yes. Now work energy theorem in rotational motion. Tell me what is work energy theorem in rotational motion में? Work done by all torques is equal to change in rotational kinetic energy, right? See, उसमें क्या है? Work done by all forces equal to change in kinetic energy, right? इसमें work done by total torques लिखो. Work done by all torques is equal to change in rotational kinetic energy. Change in rotational kinetic energy. This is work energy theorem. Same thing, linear से compare करने का, we have to apply the concept and we have to solve. करो. करो.
So can you go back for a second?
नेक्स्ट पोर्शन दे दिया. नेक्स्ट मंडे का कौन सा एग्जाम्पल?
Yeah.
व्हाट? रीड पोर्शन पूरा.
One second. So in physics we have rotational mechanics, kinematics, and dynamics of translation plus rotation motion, energy and angular momentum in translation and rotation motion.
Okay, energy and but circular motion, rolling motion not there.
No, rolling is not there.
Okay, nice. ठीक है, चलो हो जाएगा. See, this only we are doing. These all things are comes under kinematics and dynamics of circular motion. Okay, work done by all torques methods. I can write like this. Work done is equal to changing kinetic rotational kinetic means half I omega final square minus half I omega initial square. Right? Is all right. Rotational changing rotational kinetic energy means. चलो, that's all. करो. A flywheel is rotating at a rate of this much revolutions per minute. Work done is given. This much work, 80 pi joules is work is needed to increase the rate of rotation to 180 revolutions per minute. Find the moment of inertia of the wheel about the axis of rotation. I is telling to find. What is this revolutions per minute? उसको seconds में convert किया तो what is it called? Revolutions per second को we call as
Frequency?
from that omega we can find, right? 2 pi f बोल के लगाओ. Solve करो. I'll give options.
Okay, sir. 1 second. So 5 by pi.
So 5 by pi.
Yes, correct. 5 by 5 is answer. Actually, करो. Directly also you can tell.
So it should be B. No, not B. Sorry. A.
देखेंगे उनको बोल रहे. 3 objects are given: solid sphere, disc, and ring. Same mass, same radius. Amount of work done will be satisfied. किसका work done ज्यादा है? So work done is equal to change in kinetic energy, right? So moment of inertia are different.
So A.
So more the moment of inertia, more the work done. Okay. Chalo. Now we'll talk about rotational power. Now tell me, पावर का बेसिक फॉर्मूला क्या था? बेसिक फॉर्मूला पावर का
Force to velocity.
Force into
F dot, right?
yeah.
That is instantaneous power. F dot V. Now rotational motion में
R cross R dot omega. I mean torque dot omega.
tau dot omega, right? And instantaneous ठीक है, this is a formula. Copy it. No करो. Dot product you know already. Easy.
So 3 I cap plus 6J plus 1K.
Dot product में I cap नहीं cap J
Oh,
cap नहीं आएगा.
oh.
Power is a scalar quantity.
So 20.
20 watts is answer.
So what's the unit?
Watts tau dot omega, right?
Yeah, so I got
So
20.
20. Okay. Next. Calculate the torque developed by the aeroplane engine whose output is 2000 HP2 at 2400 revolutions per minute. 1 horsepower, you know already, right? 746 watts.
Sir, will you get in pi only?
No, no. Yeah, tell me. No problem. Approximate, 3 you take. Pi 3 you take and tell approximate answer.
Oh, okay then. Sir, 8. Sir, 8.125.
No, no. P is equal to tau omega. Tau is equal to P by omega.
So should we convert the revolution per minute into seconds?
कन्वर्ट करने का n 2 pi f में कन्वर्ट करो, ओमेगा आएगा. ऑलवेज रिवोल्यूशंस पर सेकंड को फ्रीक्वेंसी बोलते हैं.
Sir, I forgot to multiply by 746.
Oh, okay.
So then you'll get one big answer, no?
Yeah, फर्स्ट लेटर करें, फर्स्ट नंबर बोलो. एक नंबर तो सेम हो.
So I got 6,206.
Approximate that only. Yes. Okay. So if you use 3.15 वगैरह यूज किया तो 5937 is answer. मीटर. Okay, approximate answer. 3 ले सकते हैं. Okay. समझ आया? तो is equal to a 2 pi f डालने का and power को horse power को we have to convert into 746 watts.
Yeah, yeah, got it.
Yeah. Next. Conservation of mechanical energy. These all small topics है. Linear से compare करके करने का. Okay. Conservation of mechanical energy क्या है? Whenever when we have to apply conservation of mechanical energy, tell me. If there is no friction, no work done by external agent, then we can apply conservation of energy happily. What is the formula? Ui plus Ki is equal to Uf plus Kf. Right? Now, initial potential energy, you know, final kinetic energy, you know, whatever the things, you know, you substitute and formula and get the answer. And this is rotational. If the body is rotating का kinetic energy you have to use. अभी तक we are talking about pure rotation. आगे आने वाला है, आगे भी जाएगा and rotate भी होगा. So दोनों यूज करना पड़ेगा. Net we have to find always. Okay. चलो करो. a rod of mass m and length l hinge at a point h, okay, and release from rest from the horizontal position. So
Sir,
initially,
conservation of mechanical energy. No, madam.
we have to apply when there is a no friction, no work done by external agent. So rest se choda. Find the angular velocity of the rod when the rod become vertical. When the rod is becoming vertical, at the time, my angular velocity is how much? Now find karo. Initially, the object is at rest. This is the initial condition, right? Rest mein. So from here to here, there is no friction. There is no work done by external agent. So directly, we can apply conservation of mechanical energy and try to find the angular velocity omega of the rod. So what is the formula? Ui plus ki is equal to uf plus kf. Okay. Initial potential energy is how much? Initial potential energy. आप इधर
Zero.
भी ग्राउंड मान सकते हो ना, इधर भी ग्राउंड मान सकते हो, इधर चाहिए ना, सो मैं क्या करूँ, इधर इधर लगाऊंगा, दिस इज ग्राउंड आई एम टेकिंग एंड इसका लेंथ है एल, राइट? टेल मी ये ग्राउंड माना, सो व्हाट इज इनिशियल पोटेंशियल एनर्जी? ये
mg.
ग्राउंड से ऊपर है ना, दिस हैज पोटेंशियल ग्रेडियंट पोटेंशियल एनर्जी एम जी एच इज एल.
Yeah.
इनिशियल काइनेटिक एनर्जी इज हाउ मच?
Zero.
जीरो.
Zero.
ओके. व्हेन इट इज क्रॉसिंग, इधर फाइनल पोटेंशियल एनर्जी कितना होगा? इधर ग्राउंड है ना, जीरो, राइट?
Yeah.
और एनीथिंग टेल मी.
No.
It'll be zero.
Why it is not zero? Tell me. Why it is zero? No, wrong. Answer is wrong. Hey, potential energy रहेगा. Why? A rod है ना, center of mass को देखो. Center of mass, when it coming, the center of mass here, the center of mass, because you are taking mass, किसका mass है? You are taking only mass is here, huh? Mass is everywhere, right? So when it's coming is not zero. That is very important. समझ आ रहा है? So understanding, huh? Now tell me, इधर कितना कितना दूर में?
mg L by 2.
L by 2. So here to here है ना, तो mg L by 2 प्लस kinetic energy कितना है? When it's crossing, kinetic energy is half I.
Half I omega square.
Now करो and find the value of I also, you know, right? Moment of inertia about that object is ml square by कितना? 3. रॉड का ml square by 3. ना यूज करो.
So will you get it in root? We'll get it in roots, right?
हाँ, रूट्स में आएगा.
So won't you get root 3 G by L?
Yes, correct. Root 3 G by L.
Yeah, sir, I
So
got it.
आपको conservation of mechanical energy, we have to know when there is no friction, there is no work done by external agent. Then we can apply आराम से conservation of mechanical energy. Okay, now करो. I will go for angular momentum. Next variable, we are going for angular momentum. Very important topic. आपको चलो समझ आया? What is angular momentum? Anything you know? Angular momentum क्या है बोल के? Like linear में, see we studied till now what we studied, tell me. ये इधर फर्स्ट मास है, एंगुलर में क्या बोलते हैं? मोमेंट ऑफ इनर्शिया, राइट? हियर फोर्स है, वी लर्न टॉर्क, एंड हियर मोमेंटम है, वी कॉल्ड हियर एंगुलर मोमेंटम एल. मोमेंटम का दिस इज एंगुलर मोमेंटम. खत्म. क्या हुआ? तो आई टोल्ड स्टार्टिंग में दिस 3 पैरामीटर्स ओनली वी आर स्टडिंग, 90% पोर्शन हो जाएगा बोल के. एंगुलर मोमेंटम, कंजर्वेशन ऑफ एंगुलर मोमेंटम किया तो खत्म, डन. चलो, now what is angular momentum? देखो, angular momentum is always calculated about one point, always. Like torque कैसे किया? About one point. I say angular momentum also will calculate about one point. देखो, angular momentum of particle about a given point is defined as a cross product of position vector and linear momentum. Simply, I can call moment of momentum is called as angular momentum. Moment is nothing but r. So formula क्या है? R cross P is a formula for angular momentum. Suppose मान लो एक particle है of mass m moving with velocity v. An observer is here and position vector is r. R is what? The observer to the point object ka distance ko we call as r. Okay, and the particle is moving with some some velocity v. So आपको definitely there is the angular momentum, moment of momentum. So r into, see it is going in x direction, right? So momentum तो है. So moment of momentum is called angular momentum. It is a cross product of r cross p. Okay, so if you expand, what you'll get? R cross p को expand किया तो
Mod
r
r must be sin theta.
rp sin theta, and p in terms of mass and velocity में m into v, right? Mass into v. So कब बेटा जब तक? So magnitude क्या होगा? rp sin theta, mvr sin theta. Very famous formula. mvr sin theta is the angular momentum का formula है. And theta is the angle between r and p. Theta is the angle between r and p. देखो now r को extend करेंगे, r को extend करेंगे. r तो इधर से इधर तक only. We'll extend r like this, and r से डायरेक्शन कैसा आएगा? r से p को कर्ल करो, r से p को कर्ल करो. The thumb indicates the direction of the angular momentum. This is r cross p. The thumb indicates means it is inverse, right? Angular momentum direction is inverse. So formula है mvr sin theta, and उसका डायरेक्शन कैसा आएगा? Direction of angular momentum is always perpendicular to r and p. Already you know, cross product means already it is cross. मालूम है ना? C vector is nothing but a cross b. That means the C vector is always perpendicular to a, and the C vector is also perpendicular to b. Right? Similarly, angular momentum is r cross p, right? Now angular momentum is always perpendicular to r, and angular momentum is always perpendicular to p. And that is given by right hand rule, which we found, r cross p बोल के. तो फॉर्मूला आ गया ना? m सिंपल है फॉर्मूला, mvr sin थीटा, mvr sin थीटा आया. चलो नाउ देखो, इफ आई कैन थोड़ा और भी सिंपलीफाई करेंगे डिफरेंट फॉर्म्स में. इज ऑब्जर्वर इज अ पार्टिकल ऑफ मास m moving with velocity v. Okay, now either I extended, right? Extended, and this is theta, right? Okay, now I can write like this is r, right? एंगुलर मोमेंटम को आई विल सिंप्लीफाई फर्दर. देखो देखो ये वाला आपको मोमेंटम का डायरेक्शन इस तरफ है ना. ओके, आई एम टेकिंग द परपेंडिकुलर डिस्टेंस, आई एम ट्राइंग टू टेक. ओके, देखो इसको एक्सटेंड करूंगा, इसको एक्सटेंड कर रहा हूं. दिस इज परपेंडिकुलर डिस्टेंस, दिस थीटा, दिस थीटा, दिस आल्सो थीटा, राइट? हाँ, दिस इज परपेंडिकुलर डिस्टेंस. यू टेल मी व्हाट इज द परपेंडिकुलर डिस्टेंस, कितना है इसमें? व्हाट इज द परपेंडिकुलर डिस्टेंस? आर का इस तरफ कंपोनेंट इज आर cos थीटा, इस तरफ कंपोनेंट इज आर sin थीटा. सो फॉर्मूला क्या है? L is equal to mvr sin theta. This is the formula for angular momentum. Magnitude I'm talking about. I'm combining, देखो r sin theta को I call as r perpendicular. किससे perpendicular के? Momentum से perpendicular वाला distance वाला I'm taking. So I can call L is equal to mvr perpendicular. देखो shortcut formula, whenever angle is not given, आपको momentum से perpendicular वाला distance we should take directly. Okay, mvr perpendicular is also a formula. We are talking about magnitude only. First direction तो आपको मालूम है, extend करके r cross p करने का, right? I can do like this also, same case, v theta is observer r. Okay, I can do like this. देखो velocity को tell me the components. Tell me what is the velocity here. इस तरफ component is v cos theta and इसका perpendicular component is v sin theta and I call v sin theta को v perpendicular. किससे perpendicular है? R से perpendicular वाला. Now I can देखो L is equal to mvr sin theta is the basic formula. What I'm coming? V and sin theta I'm combining. M R V sin theta को I can write as V perpendicular. So MVR perpendicular or MRV perpendicular, all are the same formulas which we are using in the angular momentum का formula में. समझ आ रहा है? Tell me what is the formula for angular momentum? Tell me angular momentum का formula क्या है?
mvr sin theta.
Basic formula is बस vector form बोलो.
r cross p.
R cross P.
R cross P. इसको expand किया तो mod L का कितना होगा? R M P sin theta or I can call MVR sin theta, very famous formula, or I can call as MVR perpendicular, मतलब momentum से perpendicular रहने का is equal to MRV perpendicular. These all are magnitude only, all are same angular momentum का. Okay, चलो understood? Copied? Now tell me for
Yes, sir.
rotating board.
दूसरा meant to say I copied. So you can continue. You can continue.
Yeah, देखो suppose मान लो for rotating body को angular momentum is I omega for rotating body. Any rotating, like solid body is rotating about this axis. Suppose मान लो rotate हो रहा है with angular velocity omega. So इसका moment of inertia I है. So क्या होगा? I omega. देखो moment of inertia. देखो formula basic formula था ना. What is the basic formula? Momentum का formula? Mass into velocity. Mass के जगह में I है and V के जगह में omega है. खत्म. Momentum का formula only. Angular momentum. I omega we have to use. And moment of inertia is all values you can substitute, we can find the angular momentum. चलो now देखो can a particle moving with straight line having angular momentum or not? एक particle है zoom बोल के जा रहा है सीधे जा रहा है. Can we have angular momentum with respect to वो?
No.
Answer is yes. We have
So
angular
won't it
momentum.
just be rp though?
What is the formula? Angular momentum in this case में find करो angular momentum.
It'll just be mvr, right?
MVR, yes, correct. Because we can use MVR perpendicular, right? देखो momentum से perpendicular distance is this one, right? This only with respect to this point, right? With respect to this point. These are perpendiculaars. That means L is equal to MVR perpendicular is R. Whether magnitude is same or not, in all case में देखो particle is here, here जा रहे हैं. Whether the angular momentum is changing same tell me.
That's same.
Same. Why direction भी check करने का, right? Direction भी check करो.
Magnitude will be the same.
हाँ
The magnitude will be the same.
डायरेक्शन चेंज होगा.
No.
मरे
Oh yeah. Like if
Correct.
you had a specific angle with the origin, yeah, it will.
देखो ऑलवेज आर को एक्सटेंड करो एंड मोमेंटम से एंगल डायरेक्शन चेक करो. आर क्रॉस पी इनवर्ड्स. ओके अगेन आर को एक्सटेंड करो एंड मोमेंटम इज लाइक दिस. सो व्हाट इज द एंगुलर मोमेंटम का डायरेक्शन इज आर क्रॉस पी. डायरेक्शन तो सेम है ऑलवेज. पार्टिकल इज गोइंग स्ट्रेट लाइन मोशन बट डायरेक्शन सेम है, मैग्नीट्यूड सेम है. दैट्स व्हाई एंगुलर मोमेंटम इज सेम इन दिस केस में. तो मैं सो मैग्नीट्यूड विल बी MVR. ये आपको मेंस में भी पूछा है. सो अंडरस्टैंड करो MVR परपेंडिकुलर. आर परपेंडिकुलर किससे लेगा? मोमेंटम से विद रिस्पेक्ट टू ऑरिजिन से डिस्टेंस ड्रॉ करने का परपेंडिकुलर डिस्टेंस ओनली यू शुड टेक. अंडरस्टूड फॉर्मूला?
Yeah, got it.
चलो ना करो जे में क्वेश्चन करो. ऑप्शंस विल गिव. नो अभी मोमेंट ऑफ इनर्शिया सभी का कॉन्सेप्ट आ जाएगा. क्वेश्चन शुरू. ए 4 point masses of mass m are fixed at the corners of a square of side L. All are mass m, 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 m. Okay. The square is rotating with the angular frequency omega about the axis passing through one of the corners of a square parallel to the diagonal. देखो diagonal का parallel है, axis is rotating like this. इसके about the body is rotating. The angular momentum of the square about this axis is. Angular momentum चाहिए
So
about
can we
this
take the
axis.
sizes 0, L, L, 0, and then can we find the... Wait, one
J
second.
means 2020. करो. What is the rotating body का, rigid body का, what is the formula, angular momentum का formula? Rotating
I
body का,
omega
particle
square.
नहीं है.
I
हाँ?
into W.
I omega.
I omega. Okay. Now moment of inertia about this axis करो all masses का. Omega तो same है, सभी particle का omega same. So that means आपको सभी का moment of inertia ऐड करना पड़ेगा. Into omega same. हाँ करो. Understood the question? हाँ करो.
Yes, sir.
Angular momentum is simply I1 plus I2 plus I3 plus I4 times omega. इसका मोमेंट ऑफ इनर्शिया कितना है? इस मास का मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस इज हाउ मच?
0.
हाँ. नाउ इसका 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 फाइंड करने का. ये डिस्टेंस मालूम है ना आपको? मतलब अगर ये डिस्टेंस कितना है इधर से तक?
Root
Root
2L.
2L.
हाँ ठीक है, L√2. हाँ. नो वो डिस्टेंस का पैरेलल करो. नो मोमेंट ऑफ इनर्शिया आपको आता है ना ऑलरेडी. डिफाइन करो.
Sir, can't we just find the perpendicular distance at each point and add them all?
तो करो. करके आंसर बोलो. कितना आंसर है? ईच मोमेंट ऑफ इनर्शिया ऑलरेडी डन राइट. नो सॉल्व करो.
So center of mass of square is ml square by 12.
ये देखो, ये आपको 4 particles only is moving right. ये पूरा हम लोग imaginary ले रहे हैं. It's not a square body right. He told like 4 point masses, each of masses are fixed at the corners of a square of side. एक साइड लगा है ऐसा, बट फिजिकल ऑब्जेक्ट नहीं है वाला. ओके, इट्स लाइक स्क्वायर. ओके, बट आपको एंगुलर मोमेंट ऑफ अबाउट दिस एक्सिस चाहिए बोले तो सभी का मोमेंट ऑफ इनर्शिया वी आर टेकिंग एंड ओमेगा वी आर, बिकॉज़ ऑल आर मूविंग एट कांस्टेंट वेलोसिटी ओमेगा राइट. सो आई ओमेगा वी आर यूजिंग. सो नाउ फाइंड करो मोमेंट
So
ऑफ
sir,
इनर्शिया.
you can't use parallel axis theorem.
हाँ यूज करो. ये देखो पैरेलल एक्सिस थ्योरम कब यूज करेगा आपको? देखो अबाउट दिस एक्सिस चाहिए ना. यू टेल मी दिस पॉइंट कितना कितना डिस्टेंस में है अबाउट दिस एक्सिस? परपेंडिकुलर डिस्टेंस वाले वांट राइट.
Like
ये
L.
परपेंडिकुलर डिस्टेंस नथिंग बट हाँ.
L by root 2.
हाँ खत्म. द परपेंडिकुलर डिस्टेंस अगेन पैरेलल एक्सिस मत करो. मतलब ये वाला हो गया. नाउ यू कैन यूज नो व्हाटएवर यू वांट. नाउ ये डिस्टेंस कितना है इधर से इधर तक? ये
L.
मास हो गया. ये मास कितना है? ए बी एल बाय रूट ओनली.
Yeah.
नाउ ये वाला परपेंडिकुलर डिस्टेंस ऑलरेडी नो. नो कैलकुलेट.
So you get 3 ml square.
3 ml per omega. See, whenever you know about this one particle है is rotating about this axis. मोमेंट ऑफ इनर्शिया about this axis कितना होगा? mr square. परपेंडिकुलर डिस्टेंस मालूम होता अगेन पैरेलल एक्सिस थ्योरम की जरूरत नहीं है.
Yeah, so 3 ml square by 3
Yes.
ml square omega.
बढ़िया. क्या करो? थोड़ा हार्ड क्वेश्चन चूज किया, ट्राई करो.
So, but there's no figure.
फिगर आप ड्रॉ करो, रोटेटर मोशन राइट, ठीक है। Okay, done. Figure. Okay. So what is saying? A particle of mass m is projected with angle theta with the x-axis with the initial velocity v naught. Initial velocity v naught से मैं पे का initial in the xy plane as shown in figure. Calculate the angular moment of the particle at t is less than v sin theta by g. मतलब ये less than maximum height वाला time है, greater than maximum height वाला time है. Is like u by g, right? Time of ascent is 2 by g. It's less than वाला, right? मतलब somewhere particle came up to here. With respect to वो में, at this point में is asking what is the angular momentum. Angular momentum of the particle I want. Calculate. I cap j cap में है, मतलब terms में I cap j cap k cap terms में answer is there. And particle के mass है m. So angular momentum का फॉर्मूला क्या होगा?
ऑप्शंस
I cap j cap टर्म्स में रहेगा. देखो एंगुलर मोमेंटम का फॉर्मूला क्या है? m into I can write like this, m sin क्रॉस प्रोडक्ट में r cross p, right? So L is equal to r into cross mv. So L is equal to m is constant, right? बाहर आ जाएगा r cross p. Since the given options in I cap j cap, वो मतलब indirectly suppose मान लो it is reaching at this point p. So r का write in vector form. Velocity, we have two velocities, right? One is horizontal velocity, one is vertical velocity. Vx, vy. It is also write in vector form. दोनों cross product करो, will get the answer.
But
You
what
know
do we
position
take
vector?
for R? What will the points be?
Tell me, when the particle came up to here, it has covered x distance and y distance simultaneously, right?
So you have to assume it as x and y.
What is the x r value is how much? Tell me. Distance covered at this entire at the time this point t time में particle came मान लो up to here. Tell me.
So xt.
So it will
No.
be the resultant vector, right?
Vector form में चाहिए. कैसे आएगा? Tell me.
xi cap plus yj cap.
अरे I want कितना distance travel किया? Tell me first of all. Rotational motion में come to rotational motion. When a particle is thrown like this rotational motion में at time t में how much distance it travel? How will you apply equation of motion use करके?
Second one.
It will be
आपको
range like
horizontal में velocity is constant or not? Right?
Yeah.
Velocity is constant. So what is the component? What is the velocity here? Tell me. V cos theta into time, right?
Yeah.
So what is r v naught cos theta I
x,
cap?
y, v, theta.
Now tell me y में कितना ट्रैवल किया? डिस्टेंस कितना होगा आफ्टर टाइम t में? Into t, right? Into time, right?
Yeah.
Right? Because horizontal में there is a constant velocity. That's why acceleration is 0 बोल के लगा के we got only v cos theta into I cap. Okay. Next. Y में try to find by using equation of motion. Tell me what is the y velocity? याद है ये वाला? We learned distance formula. We learned velocity also after time t in rotational motion में. Distance का SC को UT plus half square लगाओ. So क्या होगा? UT means UT plus half a square. U is how much? Initial velocity in y direction is how much? U sin v naught sin theta.
Oh, yeah.
UT minus half GT square, right?
Yeah.
Into कितना? J
J
cap.
cap.
Why we are doing this one? Because आपको क्रॉस प्रोडक्ट में करके आंसर ऑप्शंस में क्रॉस प्रोडक्ट में दिया है. ओके. नाउ वेलोसिटी बोलो, कंडीशन ये बोलो. इन टोटल मोशन में आफ्टर टाइम t vx is how much, vy is how much?
V cos theta and V sin theta.
v naught cos theta I cap प्लस इसका वेलोसिटी में इनिशियल वेलोसिटी इज v नॉट sin थीटा, बट इधर थोड़ा डिक्रीज होता जाएगा ना, g is acting downwards, right?
V cos theta. V sin
v
theta.
v sin theta is the initial velocity in y direction, not here, because I told you because of g there is velocity goes on decreasing.
It'll be V naught sin theta minus GT.
Very good, super, correct. So v naught sin theta minus gt into j cap. Now you got, now do the cross product. R pura cross v, and mass is m only. Now multiply and tell the answer. वेरिएबल्स में रहेगा, आई कैप जे कैप के कैप में है ऑप्शंस.
So where will you get K cap?
क्रॉस प्रोडक्ट में व्हाट इज आई क्रॉस, सी क्रॉस प्रोडक्ट में दिस इनटू दिस, राइट? आई
Yeah.
क्रॉस आई वाला कितना होगा?
0.
आई क्रॉस जे विल बी
K.
हमारे के आएगा ना.
Oh,
नाउ सेम वे जे क्रॉस आई विल बी माइनस के आएगा, जे क्रॉस जे इज 0. नो मल्टीप्लाई वेरिएबल्स ओनली, डोंट जस्ट मल्टीप्लाई एंड फाइनल आंसर बोलो. 2010 में पूछा जे मींस. सो क्या बचेगा? L इज इक्वल टू m टाइम्स दिस इंटू दिस तो गया, ये वाला बचेगा, राइट? सो v नॉट cos theta into t into v नॉट sin theta minus gt. Okay, I cross j is k cap.
So I got
हाँ
minus half mgt square cos theta.
हाँ is k cap. Okay, this into v r cross v इसका करो, इसका मीन्स ये दोनों को माइनस k cap आएगा ना. सो क्या होगा? v नॉट sin theta into t minus half gt square into v naught cos theta and minus k cap. So minus इधर k cap. So अब एक एक इनसे मल्टीप्लाई करके सॉल्व किया तो विल गेट द आंसर एज minus half mg v naught t square cos theta k cap. So answer is minus half mg v naught t square cos theta k cap. जी मैं इस पे थोड़ा डिफिकल्ट जैसे, बट आपको देखो प्रोजेक्टाइल मोशन लिंक होगा प्रोजेक्टाइल मोशन, बट यू अंडरस्टैंड आर भूल गया क्या? एक्स डिस्टेंस में कितना टाइम टी में कितना डिस्टेंस ट्रैवल किया एक्स डायरेक्शन में. इट इज ऑलवेज सिंस हॉरिजॉन्टल में वेलोसिटी इज कांस्टेंट, सो डिस्टेंस कवर्ड इन टाइम टी इज वेलोसिटी इनटू टाइम. एंड इसका कितना वाई डिस्टेंस कवर में एस इक्वल यूडी प्लस हाफ स्क्वायर लगा रहा है, बी सेंटर माइनस हाफ डी स्क्वायर, राइट? करो. करो.
So I'll go to the washroom and come back.
Yeah. A particle of mass m is projected with a velocity u at certain angle 30 degrees. Same thing only. Point of position. About this point only, I want angular momentum when the particle is at highest point, maximum height. Mein. I want the angular momentum at this point P. At this point, it is going like this, right? M into velocity u.
Sir, once we get range, we have to half it, right?
रेंज का हाफ कर रहे हैं भाई रेंज यू आर फाइंडिंग
So, because we have to find the horizontal distance and vertical distance, right? To find R.
from this point only we are seeing, right? This is r perpendicular. This is nothing but maximum height only. H max. H max का फॉर्म क्या
So we have to use U or U cos theta.
तो and u to u cube होगा. Tell answer.
So √3 by 16 mu cube.
Yes, this is answer.
Sir, I have a doubt.
Yeah, tell me.
Sir, but shouldn't we actually find the? Sir, after I find height, what do I do?
H max का फॉर्मूला क्या है?
U square sine square theta by 2g. So video stuck.
Use MV R perpendicular. Okay, R perpendicular is nothing but the height only. Okay, and H max का फॉर्मूला you know, U square sin square theta by 2g. Theta मालूम है ना? Theta is 30.
Okay.
Solve करो.
mu into √3 O. mu into U square by 8g.
Sin
So your video is
that
stuck.
1/4
Cross back.
by 2g.
1/4. Yeah.
So कितना होगा? Answer is
You get mu cube by 8g.
and okay. M UX is how much at that point में? At that point में UX is how much?
U cos theta. Sir, won't it be m into U cos theta into U?
M into U cos theta into U square sin square theta by 2g. Now multiply करो. कितना आएगा?
So you get 1 second. √3.
Cos 30 is √3
Yeah,
by 2.
now you get √3 mu cube by 16g.
Yes, √3 by 16. So m into उसका velocity, right? उसके उस point का velocity. So क्या होगा? ux है ना? U we put actually, but u is not, right? ux, right? ux is how much? U cos 30. वो use किया. So angular momentum का formula तो same only, but हम लोग use करने वाला तरीका different है. करो. So m is given, r vector displacement is given. They're asking find the angular momentum with respect to origin at time t equal 2 seconds.
So won't the differentiation Wait,
हाँ
how
करो.
do we find velocity though?
वेलोसिटी वही ना, डिस्प्लेसमेंट से वेलोसिटी कैसे आएगा, डिफरेंशिएट करने का.
So, but won't that give omega?
अरे आपको y ओमेगा वेलोसिटी आएगा ना, डिस्प्लेसमेंट इन टर्म्स ऑफ टाइम इज गिवन, r इज गिवन इन टर्म्स ऑफ टाइम, राइट.
But isn't dr by dt
तब क्या
omega?
करेगा, दे गिवन वेक्टर फॉर्म, राइट. वेक्टर का फॉर्मूला यूज करो, r m into r क्रॉस.
Oh, okay, then got it. Fine.
अगेन मोमेंट ऑफ इनर्शिया की वजह से नहीं, अब डिफिकल्ट है ना. एक रिजिड बॉडी व्हेन इज मूविंग यूज i ओमेगा मोमेंट ऑफ इनर्शिया अबाउट दैट एक्सिस का. बट whenever the given particles are moving, ये वाला ऐसा यूज करेंगे फॉर्मूला.
So it'll be m into 4 I cap minus 12 j cap into 2 I cap minus 12 j cap.
Options are given to you.
Okay, 1 second.
Sir, minus 48 K cap.
Correct.
1 second. Yeah, minus 48 K cap. Got it.
Yes. Now angular momentum for a circular motion, tell me कितना होगा फॉर्मूला about center. Okay. In every point of time में the radius and velocity are perpendicular, right? Angular. So tell me what is the angular momentum formula? MBR sin theta. Theta is how much? Theta is angle between what? R and F. MB, right? So sin 90 कितना होगा? 1. So angular momentum is simply MBR. Whenever circular particle is moving in a circular path, always use MBR. Don't use again. आता है? चलो.
So voice is breaking again.
Can you able to hear? ऑन किया तो मुझे समझ में आएगा एक बार. आप पूरा बंद करके बैठेगा तो कैसे?
No sir, I tried switching off the camera so that the voice can be clear.
Okay, चलो. ये understood है? Whenever circular path is particle is rotating in circular path, what is the formula? MVR आएगा because sin 90 है. Always every point of time में the R and V का angle जो भी है that is 90. That's why it is MVR in circular motion. चलो, now find करो. Tell answer.
Sir, could
Speed
you go
along the
back
circular
one?
path. Huh?
Can you go back 1 minute?
Yeah. So circular motion में always use directly MVR.
Yes, I can go for it.
Then?
Yeah.
Tell answer. Angular moment of a single particle moving with a constant speed along the circular path. The term which will be constant, which will be changing, is going in circular path only. And direction, you know, right hand thumb rule use करेंगे for finding the direction of angular momentum.
So it remains same in magnitude but changes in direction.
Remains same in magnitude but changes in direction.
What? Which option?
Third.
Remains same in magnitude but change in y direction. Angular momentum का direction क्या है? Tell me. About center में.
Thumb rule.
Is all right. R को elongate करो. Velocity is like this, right? R को elongate करो. And tell me R cross V. Angular momentum is outwards. Again velocity like this. R को elongate करो. And R cross V outwards. So direction is same. Everywhere outwards only. Okay. And magnitude तो same है. MVR. So answer is both remain same. Magnitude. So
No,
So
but it's
remains
V.
same in
So, but you're doing V cross R, right? If you do V cross R only, you'll get
R
outward direction.
cross V. Right? R cross L का फॉर्मूला क्या है? M into R cross V, right? R को see from center से we're seeing, right? R is from here to here. The particle is here, right? But R को elongate करो, extend करो, and R से V को कल
Okay, sir, got it.
करो. So R cross V right hand लगा के solve किया तो we'll get the direction is same. So remains same in both magnitude direction.
Okay.
करो, calculate करो. A particle of 1 kg is rotating in a circular path of diameter is given. Rate of 10 rotations in 31.4 seconds. And angular moment of the body. Okay, angular momentum. Since a particle is moving in a circular path, angular momentum.
So what was omega formula in that in circular motion?
Only in circular motion में angular momentum का formula क्या है? MVR. Right?
Sir, I
That
got
only way to find.
4.
Angular momentum का formula is M.
Yeah, sir, I got 4.
आ गया answer?
Oh, wait, no.
Wrong.
2.
MVR. 2. Perfect. So how you can tell me?
V by doing 10 by 31.4 into 2 pi.
Yes, correct.
Yeah.
आया?
1 second. You get 20 into 3.14 by 31.4. That's 2.
Yes,
And
2 is
then
answer.
2 and oh wait, sir. 2 into yeah, 2 into 1 into 1. Yeah, 2.
Yes. So